In this video, I will give you a high-level overview of the process of developing an optimized FWP program using JunoViewer, emphasizing the two main steps involved in modeling. Let's start with a schematic and simplified view of what you are trying to achieve. Let's assume you have your network broken into uniform segments such as those shown here. JunoViewer provides you with several tools to do this. For example, you can create uniform segments with a specified minimum and maximum length using our multi-criteria segmenting tool. For now, let's assume that you have already a set of modeling segments in your JunoViewer database as an empty FWP program, and you now want to optimize the timing and types of treatments assigned to all segments. In creating a FWP program, what we want is to determine the optimal combination of engineering treatments that should be placed in different years. This activity can have several objectives or constraints, such as I could ask the process to give me an indication of the budget I would need to place optimal treatments in all years, or I could ask the process to give me the optimal treatments for a given budget scenario. Either way, what we are looking at can be somewhat schematically represented by this image. So here I have my segments like before, but I also have my modeling period represented here by the columns with years going, for example, up to 2030. And what I want JunoViewer to solve for me is, for example, if my budget is 10 million each year, where should I do what so that my network benefits optimally? In JunoViewer, there are two core processes involved in the optimization of treatments. First, there is the consideration of alternatives on each specified modeling segment to determine the best viable treatment to place on that segment. Second, we need to scan the list of treatments or projects selected in the first step and choose the optimal combination of projects subject to the constraints of our budget and specific network conditions. Let's look at each of these two steps in more detail. So the first process focuses on each model segment individually, and then for each segment we consider all the possible treatment combinations that are triggered by the current and predicted future condition on that segment. For example, here you can see the model is considering the condition of segment 4. Now, depending on which type of model you run and also how your triggers are set up, JunoViewer might trigger just a single strategy, or if you are using a more theoretical modeling approach, a whole bunch of strategies such as the set shown here. In this case, where you have a whole bunch of possible treatment combinations, JunoViewer will pick the optimal treatment strategy based on the specified criterion such as the incremental cost-benefit ratio. If you are using a more heuristic or pragmatic approach, you could have your trigger set up in a way that only the most cost-effective treatment is triggered. We will get into these two different approaches in later videos. Once we have for each segment the optimal treatment strategy, JunoViewer will now look at each year and decide which combination of projects to choose. As you can see here, in 2019 and 20, there are only 4 projects that involve treatments in that year. If my budget allows me to do only 3, which 3 should I do? It may seem trivial if you only have 4 treatments to consider, but imagine if you have 800 potential projects and you can only choose 100. Which combinations do you choose? It gets complex very quickly. Depending on the complexity of your model and the size of your network, JunoViewer can use a variety of techniques to optimize the treatment set. At the more idealistic end, JunoViewer can use dynamic programming to solve the linear programming problem, which maximizes benefits for a given budget. On the other end, a simple ranking procedure may be more appropriate for more complex problems such as those involving groups of treatments, such as those on dual carriageway freeways, which have to commence in the same year. Remember that JunoViewer is a framework. As such, our deterioration model is highly customizable at several levels, which means we can build a fit-for-purpose solution for any situation, even those involving highly complex situations where adjacent treatments have to meet surface-level constraints or where groups of segments need to be treated at the same time. If you would like to learn more about JunoViewer's powerful modeling framework, or if you'd like to receive notification emails for new videos such as this one, then email us today at info info@lonrigs.com. Thank you for watching.